Hello there, it's Lana talking, and I received a question about this one, which is 7-2 number 13. So let's make it bigger for an example. All right, so we're going to find the z-score such that the area under the standard normal curve to the left is 0.31. All right, so the easiest way to look at this is with lovely stat crunch. So let me grab the calculator's normal, and we're going to use the standard, which is fine. And you can see that's the standard normal curve. It's got a mean of 0 and a standard deviation of 1. When they ask you for z-scores, this is the curve they're talking about. All right, now they want the area to the left to be 0.31. So I click compute. Oops, sorry, I did that wrong. My fault. This is the area. All right, so this part will be the area. This part in here is your vertical bars. Right, so if ever you get kind of confused. So area over here, vertical bar over here. And there we have it, right? This little red area over here is worth 0.31. Remember, the entire curve makes 1 because we learned in chapter 5 that the probability distribution must sum to 1. And then the z-score can be negative. Probabilities can't be negative, but the z-score can. Because 0 is in the middle and we're over on the left, it's going to be a negative value. All right, now if I wanted to copy this and paste it somewhere, right-click, copy the image, go in here. This is 7.2 number 13. I'm going to show you with a couple different methods. So stat crunch, paste special, device. There we go. All right, so there's our answer. So the answer is z is equal to negative 0.496. How many decimal places did they want? Oh, so they want 2 decimal places. Ooh, so that's interesting. So if you do 2 decimal places, that would round, the 6 would round the 4, 9 up to 50. So negative 0.50. All right, so there you go for that. Now let's show you with, well, let's do Excel next. So if I do Excel, I need to know my mean, which is 0, my standard deviation, which was 1. Then I need to know the area, well, actually the left tail area, because that's what Excel takes as standard. In this case, it was 0.31. So the z-score is equal to norm dot, technically you'd use S inverse, but I'll just keep you guys using the same thing every time. So it's norm inverse. The probability is 0.31, comma, the mean was 0, standard deviation is 1. And there you have the same value. Oh, rats. There we go. Actually, I'm going to put this in here. I'm going to have this show up like this. So you can see it's 0.31, comma 0, comma 1. Just like that. Beautiful. All right, so there's that answer. Technically, this part is the answer, so I'll highlight that. All right, now what about the calculator? Calculator is another great way to do this. All right, so let's look at that. So the TI-84, which I like better than Excel personally. And just as a warning, once we hit chapter 7 is about the last time you're ever really going to use Excel. Maybe chapter 8, but that's about it. Excel is cumbersome from this point on. You're much better off with either stat crunch or a calculator. All right, so we would use inverse norm. And just like Excel, it has to take the left tail area, which in our case is 0.31. 0 and 1 is standard because it was the standard normal curve. Press enter, and there you have it. Same answer. Okay, so that's the beginnings of how to find z-scores if you're given areas. Don't forget that Excel and the TI-84 both require left tail areas to be given to them. So if this wasn't a left tail area problem, you'd have to find the left tail. Stat crunch is nice because you can actually see a picture of what you're doing. If you're in a face-to-face course, of course, you'll be drawing pictures like this all the time as you do these problems. All right, I hope that helps.